Hey Calculus, we're ready for 7.5 and we're doing area between two curves, and it's just an application of integration. And recall that if I were to ask you to graph this, and I'm going to use some Algebra 2 type knowledge, if you recall, negative b over 2a is what we did to graph this function. So negative of negative 2 would be positive 2 over 2 times negative 1/2. And what I'm doing right now is I'm figuring out that the axis of symmetry is at x equals negative 2. And if I were to plug in negative 2 in for all these x's, squared would be 4, negative 1/2 of 4 would be negative 2. Let's see, it would be plus 4, so it would be 8 minus 2 would be 6. And that's my vertex, and then crosses the y-axis at y equals 4 if I plug 0 in for those x's. And then again, the axis of symmetry goes this way as well. So we have this curve. I don't know exactly where it crosses the x-axis. I'm just going to put a random dot over here. And same thing, because it's symmetrical, somewhere over here. It doesn't really matter. But as you recall, the definition of the integral is really the area under the curve from negative 5 to 0, and maybe in a light purple, so I'll highlight this. Oops, I meant to use purple though. This is the area that we are finding, and maybe I'll even do it in one highlighter so you'll see all of that color all the way to the x-axis. I'm not being very clean about this. So that's what that represents, and if I were to do the problem, I'd be doing the antiderivative, so it'd be adding 1 to your exponent and then multiply by the reciprocal. So negative 1/6 is 1/2 times 1/3, and then minus x squared. 2 divided by 2 is 2, plus 4x from negative 5 to 0. What's nice about all these zeros is we're going to get 0 and then minus negative 1/6 times negative 5 to the 3rd power. Minus, well, that'd be 25. What's that? Minus 20. And maybe even go to a calculator, but I'm going to jump to the answer key. Excuse me. Where he got an answer of 145.6 square units. I'm not going to worry about the units, though. I already forgot what the number was. 145 over 6. And we could even go to a calculator, because right now I'm not worried about can you do the algebra. I'm worried about do you understand the concept. So then in the next part of this is, what if I ask you to do g of x from negative 5 to 0? So let's change colors. And I'll do this blue color. Well, that has a y-intercept of 4. And that slope is up 1, right 2. But we actually only care about this part. So the intent was that they cross at the same value. And then if I were to find the integral, so I'm looking at this piece now, what that tells me is this area right here. So what's that area? Well, if we did the integral, we'd be adding 1 to the exponent and then multiply by the reciprocal. So 1/2 times 1/2 would be 1/4. Plus 4 times x from negative 5 to 0. And again, plugging in 0 for both those x's will give you 0. And then minus negative 5, once you square it, it would be 25, positive 25 fourths. And then that would be minus 20 again. And again, I'm going to jump to the answer key. You get 55 fourths. So the main premise with this problem is back to the directions where we're asking for the area between the curves. So before I jump to the conclusion, what do you think the area is between, the parabola, the quadratic function, and the linear function that we drew? And my goal is that you're thinking about, well, if I did the area of the parabola which has more area, which is pretty evident from how we did the problem. And then find the area of the linear function, which is smaller, and we subtracted the two, then we would be ending with that area. And that should make sense, because think of it, is the purple highlighter includes this blue highlighter. So if I want to just find the area between the two curves, what I should be doing is subtracting, or I'm erasing right now, but made it look even worse, is, your operation is subtraction between the two of those, which is exactly what they do on the next one. What do you suppose you would do to find the area? That answer would be to subtract the two areas. So if you did that, you could either get the exact answer of 125/12 or 10.417. Well, there must be a fast way of doing this. All right, and that fast way would include this. So what they're trying to get you to realize is that we can just do one operation. And the reason why we set it up like this, is notice what will happen between subtracting the pieces. Now notice, as I write this out, that -1/2 x squared, I'm doing the upper function first. And what do I mean by upper? Is the one that's that goes higher because the area is larger. And then this one would be the lower function. So -1/2 x squared minus 2x plus 4. That quantity minus the quantity of 1/2 x plus 4. And it's very important that you do quantities, because you have to distribute that minus in there, and these 4's will go away. So if you were simplifying this, so that would equal -1/2 x squared, -2 minus 1/2, so -4 halves minus 1/2 would be -5 halves x dx. And now it makes the problem a little bit easier that we're doing the integral. I mean, we already did that piece earlier, so I don't feel like I need to explain that. And then add 1 to your exponent and multiply by the reciprocal. So we're looking at 5/4 from -5 to 0. And again, I'm going to jump to the answer key, as we've done pretty much all of the work we need to. And I would anticipate you guys using a calculator on this part. But what you should notice is that we have found the area between the graphs of f and g. By the way, feel free to pause the video at any point, write down everything you want. So now we have a general way of finding the area between two curves, is subtracting them. And notice he writes it using the correct math lingo, where the upper function is f of x. F of x is greater than all values of g of x. The other thing you should notice, and I mentioned it, is that -5 and 0 were where these two functions intersect, because we have a lot more work to do if they do not intersect at that place, or if they intersect at more than one location. Okay, so if you didn't get this written down, hit pause, write down anything you need to. And I think our notes will take us to special situations. So as you look at this, if we had a full year in pre-calc, we would have learned that this curvy function is the sine function. And y equals x cubed minus 4x would be this other function. By the way, because the integral will give you the positive or negative answer, if you ever get a negative answer for area, what you can do is you can absolute value. Area needs to be positive. So if you ever accidentally do this incorrectly, but you get a negative answer when it should be positive, that might be why, is you accidentally did the lower function minus the upper function. But because the graph is given to us, it's pretty clear that these two graphs intersect at 0 and 2. So then you take your upper function, which is that sine of pi x, minus the other function, whoops. Notice how I'm going to write it though, x cubed plus 4x, because I'm technically distributing the minus into the problem, dx. So now I can find the integral, which the antiderivative of sine would be, well, a couple things. The derivative of cosine is negative sine, so I need to make sure it's negative. You leave pi x alone, and I'm just thinking about, well, if the chain rule, I would say you leave pi x alone, but then you take the derivative of pi x, which would be pi. So I need to go backwards, so I need to divide by pi. Now we're looking at 1/4 x to the 4th power plus x squared. Dividing by 2, or multiply by the reciprocal, and you get 2 there, from 0 to 2. So what do we have? We have negative 1 over pi. Well, cosine of 2 pi, you might need a refresher on where 2 pi is. Well, that was a terrible unit circle, but we care about that order pair where cosine equals 1. Let's see, 2, 4, 8, 16 divided by 4 would be 4. 2, 4, 8. And now I need to plug in 0. Now make sure you actually plug in 0 because cosine of 0 is still 1. Now plugging in a 0 here to the 4th power is still 0. 0 here is still 0. So make sure that you do at least the cosine. And what you should notice is that these pi's will cancel. Negative 4 plus 8 will give me exactly 4 for my area. So this could definitely be a problem on a no calculator question. Not that difficult. Obviously, once you get practice with it. If you don't like my way of doing the problem, you can see how the author went ahead and did this. He also kind of did the U substitution here. If anybody needs U substitution still to be able to do this problem, I 100% support that. And he even split it up, which I would not do. I do like that he showed the arithmetic as to why we know that these are zeros at 0 and positive 2. But the graph gave that away as well. So I'm going to end this video here. I don't think I have enough time to do any more problems, so I will see you in the next video to explain more area between curves.